Hello and welcome back to Quay Does LeetCode. Today I'm doing problem number 703, kth largest element in a stream. So for this problem, you need to design a class to find the kth largest element in a stream. Note that it is the kth largest element in the sorted order, not the kth distinct element. So that means that if you're given a list 1, 2, 2, 3, and a k equals 3, then you need to find the first largest, second largest, third largest is this 2, not 1, which would be the answer if it was the distinct elements, but it's the sorted order. So this class, you have an initialize function where you're given the nums, the initial nums. So you initialize the object with the integer k, which is the for which you need to find the kth largest, and then the stream of nums, and you store that in some way, and then you have another function, add, and add appends the integer val to the stream and returns the kth largest element. So how can we solve this problem? Well, one thing that we could do, a brute force approach, would be to have a list, and your stream would be, you'd save all your numbers in your stream in a list. And what you would do when you needed to add a number and get the kth largest is you would append to the list, and then you would sort the list, and when you would sort it, you could just sort the list and then get the negative k index, and that would give you the kth largest. So for example, the for this list, if you wanted to get k equals 3, then you would just return the list at negative 3, and that would give you this number. So this would run in O of n log n time, because for adding, because it takes O of n log n time to sort. So the question is, can we do better than this? Well, we can do better than that if we use a data structure known as a heap. So the important thing about a heap is it lets us find the min or max in O of 1 time. So if we had a heap of size k, then our kth largest, and we used a min heap, then our kth largest would actually be our min element. So if we had a heap, so let's try this out. So let's start off with our heapifying our list. So we have 4, 5, 8, 2. So we know for a min heap, the min element is going to be the first one. So the root, so it's going to be 2. And 2 is going to have a child of 4 and 5 and then 8. So now we've heapified our stream. And now we're going to add 3. So we're going to add 3. So we add a 3 here. Now we need to heapify our stream again because now it's not a true heap. So what we do is we check and see if the parent of this 3 is greater than it, and it is, so we can switch these. So this 3 moves here and 4 goes here, and now it's heapified. So now we want to make sure that this is a heap of size k, and k equals 3. So what we're going to do is we're going to pop from the heap. And the reason we're going to pop is if we have this list 2, 3, 4, 5, 8, and we want to find the kth largest, so that's and we want to find the kth largest, and where k is 3, we're only going to find the kth largest. We're going to find the kth largest here. So we don't need these top 2 elements because we want the min element to be the one that is the kth largest. So we're never going to find it in this 2 or this 3. So we need to pop the 2 lowest values out and make this make this of size k. So we're going to pop this 2. So we pop the 2, and then we replace this 2 with 4. So now we have 4, 3, 5, 8. So the property of the min heap is not yet been fulfilled. So we have to heapify this because this 3 is less than this 4. So we switch these 2. So now we move this 3 here and we move this 4 here. And now we're still not at our size k. So what we do is pop this 3 off. So then we have, and then we bring the 8 up. So then we have 8, 4, 5, and then we need to heapify this again. So we switch these 2. So this is 4 and this is 8. And then we get our min. So now we have a heap of size k. So now we get our min, and our min is 4, and that's the answer right here. So how long does this take? Well, the first thing we have to do is we have to push onto our heap. So heap push, and that takes O of log n time. Then we have to pop from our heap as many times as it takes to make our heap of size k. So that could be, so our pop is O of log n time as well, and we could pop up to n minus k times. So that would be n minus k times. So that's better than this would actually be a log k. So that's actually better than O of n time. So and then getting the min would just be O of 1. So that's significantly better. So let's code this up. So the first thing we need to do is get our data. So our self.storage, that's what we're going to call our stream data that we've got, and we're going to say equals nums. And then we're going to say our k, we're going to have a variable for our k, so we're going to say self.k equals k. And our storage, we're going to heapify our storage, so we're going to turn this into a heap. So we're going to use our heap q library dot heapify, and we're going to give it self.storage, and that'll turn it into a heap. Then what we're going to do is we're going to, so now we're going to add. So what we're going to do is we're going to push onto our heap. So we're going to do heap q dot heap push val, and we're going to give it self.storage as our heap, and we're going to give it val to push on. And once we push onto there, we need to make sure our heap is of size k. So we're going to say while the length of our heap is greater than k, then we're going to pop from our heap. So we're going to say heap q dot heap pop, and we're going to give it self.storage, and we're going to keep popping until it is of length k. So it'll stop when it's at length k, and then we just need to return our min value. So this is a min heap, so our min value is at self.storage at the first spot. The top spot is going to be our min value, and that is the code. So let's run it. So I should have said self.storage is less than k, is greater than k, and I should have said self.k, not k. And it's giving us the correct answer, so let's submit, and it was accepted. So that is how you find the kth largest element in a stream, and we can see that it is pretty efficient. So thanks for watching, and I'll see you in the next video.